People sometimes believe that organizational behavior is simply a collection of common sense ideas because the theories seem to be obvious. So if it's all such common sense, why do we need organizational behavior research? And why do we need to study these theories? Let's take a look. The answer is that common sense isn't so common. People don't always agree. If 10 people see the same leadership interaction, you may have 10 different common sense perspectives on what leadership is and how it works. Even if you don't find 10 different perspectives, you'll certainly not find perfect agreement to the same phenomena. Another answer is common sense isn't always right. Findings may seem like common sense after research is done, but beforehand, we don't really know what's going on. So it isn't just common sense. We need science and research because it's built on careful and systematic testing of assumptions and conclusions. This process allows us to evolve our understanding of how things work, and it allows us to learn when goals, confidence, satisfaction, cohesion, and rewards affect outcomes and why it happens. That's why you need to learn the theories and why you can't just operate on common sense. Organizational behavior is the study of human behavior in organizational settings, of the interface between human behavior and the organization, and of the organization itself. Although we can develop a good understanding of many of the norms, expectations, and the behaviors of others by living and working with people, there are many things that are not well understood without more systematic study. Decades of research have both reinforced some of the things many people inevitably believed and identified as common misunderstandings or misconceptions about organizational behavior. Rather than relying on experience or intuition, or just assuming that ideas are correct because they seem to make sense, the scientific method relies on systematic studies that identify and replicate a result using a variety of methods, samples, and settings. The scientific method, as you see here, begins with theory, which is the collection of verbal and symbolic assertions that specify how and why two or more variables are related and the conditions under which they should and should not relate. Theories describe the relationship that are proposed to exist among certain variables, when and under what conditions. Until they are proven to be correct, theories are no guarantee of fact. It is important to systematically test any theory to verify that its predictions are accurate. The second step in the scientific method is the development of a hypothesis, or written prediction specifying expected relationships between certain variables. Hypothesis testing can be done using a variety of research methods and statistical analysis. For our purposes, assume we collect data on our predictor, or independent variable, and our criterion, or dependent variable. We can then analyze the correlation, observed R, between the two variables to test our hypothesis. The correlation reflects the strength of the statistical relationship between two variables. Rather than answering the question with a yes or no, the correlation answers how strong the relationship is. A statistical technique called meta-analysis is used to combine the results of many different research studies done in a variety of organizations and for a variety of jobs. The goal of meta-analysis is to estimate the true relationship between various constructs and to determine whether the results can be generalized to all situations or if the relationship works differently in different situations.